Hello and welcome to the course. My name is Paulo Farias Navarro. I'm the founder of Zenba. Throughout this course, you'll learn the basics of the AngularJS framework and you'll be able to build a single-page application such as the one I'm showing you, which is an expenses tracker. You can add new entries, enter different values, have some validation going on, and then you can modify some of these. You can modify all of these entries and also remove them. So the main goal of the course is for you to learn the basics of the AngularJS framework so that you can create interactive websites and single-page applications. The requirements for this course: you'll need basic to intermediate web development skills. You have to be familiar with HTML, CSS, JavaScript, Ajax. In order for you to run the examples in Angular, if you just double-click on the files and they open in your browser, they might not work. Because of browser security policies, you need to run them from a local or remote web server. So please install something like Apache or any of the many other tools so that you can run the course examples. You'll need a code editor. You can use whichever code editor you're familiar with. You will be using Sublime Text throughout this course. And a web browser. We'll be using Google Chrome. So the course will be structured as follows. We'll begin by covering the basics of the Angular framework, and we'll move on next to the actual project. So let's get started now and talk about some of the basics of the Angular framework. In this lesson, I'm going to cover some basic concepts of the Angular library. Let's talk about single-page applications. I'm going to start by describing what the traditional way of making web applications is, and then I'll talk about the newer way, which is the single-page application way, and it's what Angular is used for. So the traditional way is that you will have your website, and in your web application, whenever you want to do something, example, you click on a button, you go to a certain section of your page, there's usually a request that goes to your server. In your server, you'll have a traditional MVC framework that will send you back a view, a full page for that new place where you want to go. And then once that received, your web browser will do a full page reload, basically. It will be a full page redirect. It'll direct you to a new page, basically. And that will involve that everything in your page is being loaded again. Namely, the menus, the sidebars, everything, even though what you requested maybe only had to do with a small part of your page. Now, in single-page applications, you will do requests to your server, but the responses are not an entire page. You're always on the same page. The response is going to be instead usually a JSON object or HTML, could be XML as well. So you're not receiving an entire page each time that you do anything, because that makes your web application just feels very slow. It's not like you always have to use this approach, but a lot of times it's just nice to. This is the way the main web applications that you use work. They only reload they only change certain parts of the page as data is received from the server. So AngularJS is a framework for web applications created by independent developers and also with the big support of Google, maintained by Google today partly as well, and the community, of course. It's an open source framework that addresses some of these challenges to create single-page applications. It extends HTML so that it's more suitable to create these type of pages. And it also allows you to separate the views, the presentation, from the actual logic of your page. It is based in an architecture called MVC, which stands from Model View Controller. And let me explain you how what that translates to in Angular. This is all happening on the client side, okay? So you will have, for example, a model, which will be, models are basically variables, objects in JavaScript that can store any kind of information, and you want to show this model, in this case, information about a user in a view. A view is what the person sees at the end, what the user will see. It's what's rendered on the page. So the glue between the two things is a service called scope, and that all occurs in the controller. So basically, what you usually do is that you will attach your models to your scope, and your scope can be accessed by the view you can show stuff that's available on your scope. An important concept here is that of data binding, which can occur both ways. That's why when you read about Angular, you read about two-way data binding. Example: you're showing some model on your view, and that model changes on the controller or anywhere. You can even do it on the browser's console. You change your data. The name of the person changed. The view will automatically update. So that's one of the magic things about Angular. It's one of the reasons why everybody loves Angular. It's just because it's so efficient to work this way. And it also works the other way around. You can have a form that's linked to a model, and if you change the data on the form, it's also changing the actual model, and therefore it's changing all the data on the other views that refer to that model. We will cover all of this in detail in the course. There's real lessons for each one of these topics, and we'll really dig into this so that you can use it right away in your projects. Something about Angular is something called expression. So this is how you would show some stuff on your view by using the double curly brackets. And then there are also directives, which are HTML elements that you'll add to your page, and Angular knows what they mean. You can also create your custom ones. So for example, you could create a custom HTML element for a user profile, and then just place it in different places of your app as if it was a HTML code. But this will be linked to a controller, and there'll be a whole bunch of logic behind. So I'm covering this all in a very abstract way at the moment. It's all a quick intro. This is all going to make a lot of sense once we start using it. How to get Angular? You can just go to their homepage, angularjs.org. You can download from there directly. If you click on download, you'll also be asked if you want some of the additional modules to be included. We'll use the route one later on in the course. You can also just get it from GitHub. And if you're a more advanced user and you use Bower, you can also include it using Bower or any other client-side package manager. Some of these new cool toys that are out there for some users who like to use a lot of command line. The documentation here is your friend. Make sure you keep this open when you're working with Angular. Read a bunch of stuff. Every time you get stuck with something, take a look. The answer might be there. It's a lot of examples. There's also the official community. There's a lot of people who will participate here, and a lot of people who are beginning with the framework post their errors here. So if you're having a particular error message or some sort of code in the error message, you don't know how to debug it, where to find it, this is an excellent place. You might already find someone who's got the same question, or you can ask it there, and a lot of people are going to help you. So now it's time that we begin coding. In this lesson, we're going to create our first Angular application. It's not going to do anything yet. We'll add all of that later. We're just going to initiate it as an empty module. We start with this HTML code. As you can see, we're including the Angular library and a file called app.js, which is where our code is going to go. It's empty so far. The first thing we want to do is specify the root of our application. We'll use a directive called ng-app, and we'll give it a name, expenses app. That's going to be the name of our app. What's a directive? What did I just do? Directives are elements that you place in your HTML code and that tell Angular that certain behaviors will take place on where those directives are. In this case, by setting the root of our app in the HTML node, we're telling Angular that the scope of our application will be everything that's inside of this particular node. In order for us to include logic in our app, to include controllers and functionality, we need to create a module. We're going to add a new module for our app. Let's create a new variable. I'm going to call it app, but it could be called something else. And we're going to refer to a global object called Angular. That object is available when we include the Angular library. And we're going to type module, so we're creating a new module. The name of this module is going to be expenses app, so we're specifying the name of our application. Modules can have can depend on our modules. You could inject modules inside of other modules so that they can use those other modules' functionality. In this case, we're not injecting any module, but we still have to specify the dependencies, which in this case is going to be an empty array. So there you go. We've created a new Angular app, a new module. It doesn't do anything yet, but we'll take care of that later by adding a controller. One of the reasons why people really love the Angular framework is because it allows us to pass expressions. We put an expression on our HTML code. For example, the value of a variable, in this case a variable called name, and it will show us the value of that variable on the page. So as opposed to, say, using jQuery where you would have to find the particular DOM element and change its value, in here we can just pass them as expressions. Now, where does all of this take place? There's a concept called controllers. We're going to create a controller now. They are a particular type of objects in Angular that allow you to glue what's going on in the view with changes in the model. We do that by accessing an object called scope. Whatever we pass to the scope is available for us to use in our HTML. So let's build that up to make it more clear. I'm going to start by creating a new controller and putting it in our module. We'll give this controller a name. It will be called expenses view controller. I mentioned that we need this scope object, so we need to pass that scope to our controller. The way you pass parameters to a controller is going to look a bit strange. I'm creating an array basically, and I enter the name of the parameter as a string. If I had more parameters, I would have to enter them here, comma separated. At the very end of the array, we define a function, which is the constructor for the controller, and in here we pass the object again, the parameter. This is where all of the logic of the controller will take place. Now, why are we writing this as a string and also passing it as a parameter? The reason is, it's not relevant right now, but just so you know, the reason is because when you run minification algorithms, which are algorithms where all of the JavaScript is packed together, the variable names are usually replaced by letters. So this will be called maybe A or B or C. And then we'll lose track of what the original object was. So by passing the string, Angular will know, even if it's minified, that this refers to the scope. Okay, so let's define that name variable. We'll put it in our scope. Everything that we put on our scope will be available in our HTML to use as expressions. So the name will be Pablo, and we still haven't attached the controller to our HTML code. You can have multiple controllers on a page. What you need to do is attach it to a particular DOM element. Whatever is inside of that DOM element is going to be the scope of your controller. So for example, if I attach the controller to body by using ng controller and writing the name of the controller, everything that's inside body will be the scope of our controller, and we can access these variables from there. So if I reload the page now, we will see the name, because basically what's happening here is we are attaching controller to the body element. Again, you could have multiple controllers on different sub-elements. That controller is called expenses view controller. We defined it here. And inside of that controller, we define a variable called name, with value Pablo. And we show that using an expression on our HTML page. In this lesson, we're going to talk about the concept of data binding. Data binding means connecting data from the view to the data of the model that's behind this view. So for example, we have a value here that says 10, and that's stored in a certain variable. If that variable changes, the magic in Angular is that the value that's shown on the screen is also going to change. So that's absolutely revolutionary when it comes to front-end development, because with other libraries, you would normally have to, upon a change of the variable, you would have to find the DOM element, select it, and then modify its value in a manual manner. In here, that's handled for you by the framework. Let's look at this controller. I'm defining an object called expense, which has two properties. description, a string that says food, and amount, 10. We're also creating another property here called phrase, which says the sky is blue. Let's take a look at our HTML. We have title 1, phrase, and then we're showing the description and the amount of the expense. Take notice how we are just accessing the object directly as we created it in our scope. So what I want to add now is a button that will allow me to change the amount. So I'll show you how by changing the amount in the model, the view will automatically change as well. So let's say, this is going to say increase amount. Let's close that up. And this will display a button that doesn't do anything, of course. We need to use the directive ng-click to run a certain method when that button is clicked. This method is going to be called increase amount. We haven't created this method yet. Let's do that now. We will pass this method into our scope as well, so that it's available to use as an expression in a directive. This is going to be a function, and all that function is going to do is modify the value of amount by 1. Let's reload the page and test this. So see how I'm increasing the value of a variable that's passed to our scope, and we're showing that with an expression. Nowhere in the code I'm telling the framework, hey, go grab that particular node of text, change its value to this new value. I'm not doing that anywhere. It's all done automatically for me as variables here are binded. There's a binding between the amount in this expression with the value of expense.expression in our controller. That's one of the magic things about Angular. It's one of the reasons why so many people love and use this framework. We know that Angular links the value of the expression with the value in the controller, right? So we know that if we increase the amount, what's shown on the view is also going to increase. But that's not where it ends. There's actually a two-way data binding in Angular. So if we were to modify this value in our view with a form, for instance, an input field, it would also change the value of the model. So that's why it's called a two-way data binding. You can just work it one way like we did here, but you can also work it two-way, and that's what we'll do in this lesson. Let's add some input fields, and I'm going to put those in div containers. So I want to have one that's going to be for the description, type text, and I'm also going to add another one for the amount. Let's have it as a number field. You could also have something like a text area, which is going to be for the phrase. Now we have the fields here. How do we link these fields to these variables? We need to use the directive called ngModel. ngModel allows us to specify what model this particular field refers to. In this case, this one is going to be expense description. This one's going to be expense.amount. And this last one will be simply phrase. That's the name of the title. If we reload the page now, I forgot the R. See how automatically all of these fields are taking the value of their corresponding models, because we made it very explicit that this input refers to this particular model. What happens if I change it? If instead of food I write the Spanish word comida, which means the same thing? It changes dynamically. It's like magic. So that's two-way data binding in action. Basically, on one end, we're changing the view, and it's changing the model. And as the model changes, it also changes the view. What we're seeing here reflects the model, and this is modifying what happens in the model. This is extremely powerful. This is two-way data binding in Angular, one of the main concepts, main features, amazing features of AngularJS. In this lesson, I'm going to show you an Angular feature that's absolutely going to blow your mind. How can we show repeated elements without having to write custom loops and iteration or very complex DOM manipulation functions? Let's do it. So, I have in my controller an array which contains different objects. These in particular are foods. Each food has a name and a list of ingredients, which is an array again. This could be something that you loaded from your database, that you read from the internet, that's something that was stored locally using local storage. It doesn't matter where this came from, but the way we can work with this in Angular is absolutely amazing. What I want to do is show a list of all of these foods, and on each one of those lists I also want to show all the ingredients to the sides. So when I hear about lists, I'll think about unordered lists. In this case, that's what we'll use. The element that we want to repeat is the list element, because we want to have many of those list elements. It could be this could be used for anything, for div containers, for absolutely any DOM element. In this case, it will be for list. So we will use a directive called ng-repeat, extremely powerful, and we want to grab each item out of items. Items is the name of the array. Whichever name we put here is optional. This could be for every X in items. We'll just call it item to keep the semantics, the meaning, so that we don't get confused. So this is just by doing this element will be created multiple times for each one of them. But what I want to show is the name of this recipe or this food. So I'll do item.name. Each one of these objects will represent a specific object from our list. So this gives me all of the names, and now I want to show all the ingredients, and I'm going to do another ng-repeat, this time for a span that will have color blue to make it a bit more distinctive. And let's close the span. We want to repeat this as well. So this in here we'll do ng-repeat one more time. In this time we'll go for each ingredient in item.ingredients. In this case, ingredient is just a string, so we can quickly display it like this. That will give us all of the ingredients. Now you probably want to have a space in between so that it's more readable. That looks better. So this is a basic use case of ng-repeat, how you can so easily, you can start using this today on your current project because it's so powerful, so simple. This can be any kind of element, list, divs, anything, subform elements. So that's ng-repeat. Throughout the following videos, I'm going to be creating an entire web application from scratch using Angular. It's an expense tracker where you can add new entries, enter the corresponding description, price, a date, and you can of course edit entries and delete entries. We're using Angular plus some other tools that about which I'm gonna talk in a second. Since this is a client-side course, we're not covering the server side of things. So you can create the server side however you want, with whichever tools you normally use, whether it's Node.js, PHP, Ruby on Rails, and other technologies. But we are covering how to connect to a server side. We are covering how to push this information to the server. So when you create a new entry, we're doing an AJAX call to a server, and you could of course implement your own logic there. For the user interface, we're using Bootstrap. It's not a requirement of this course to have used Bootstrap in the past. You don't need to know anything about it. We're just going to include it. And the elements that we'll use, such as this list or the type of buttons, are all very simple code snippets they're basically just HTML with certain classes. Since we're including the Bootstrap CSS file, that will give it the nice look that you see on the app. Bootstrap requires jQuery, so we're also including jQuery, but we're not using it for anything else. The other library that I've decided to include in this course, it's an utility library that I use very often called _.js. It's a very lightweight tool belt. It's a set of basically helper functions that make it easier to work with collections, with objects, with arrays. So that's our application, and now let's take a closer look at the user interface. In this lesson, I'm going to show you how I've implemented the user interface. Not how I've implemented it with Angular, but before I created the Angular app, I actually created full HTML templates of the two screens that we'll have in our app. The two screens that we have are the expense listing page and the form, which is used for both creation and edition of entries. So I put them in different HTML files. This is again not the implementation in the actual app. These are the mockups basically before I started coding. But I wanted to show you a little bit of the Bootstrap aspects. If you're very familiar with Bootstrap, there's not going to be anything new for you in this particular video, but if you haven't used it, this might be a very quick crash course on how it works. So basically, I included Bootstrap, the minified Bootstrap CSS, and the normal Bootstrap library, the JavaScript library at the bottom of the body. For the navigation bar, if we look at the documentation, that's called a nav bar, and its code is very, very simple. You simply defined a nav element with certain classes, and there's different options for the kind of nav bar that you want to have. This snippet here, for instance, shows you how to have an image there. So that's exactly the same thing that I did. So this part has to do with the navigation bar, and then we have a main container which has all the content. In that container has a row and then a column that will the content that's inside will show in one column no matter the resolution. So this is normally used for when you want to have you could have different columns with different amounts of content. You can find, of course, the documentation on the Bootstrap website. This is far beyond the scope of this course. For the list group, we used basically the code that comes with the documentation, which is this one here. So all you do is create an unordered list, give it a certain class, and then you can add all the entries that you want. In this case, I hard-coded a few of the entries. For the buttons, you just create buttons and give them a class of button so that Bootstrap knows it needs to style that as a button. And then for the color, there's different options. There's the danger one for the red, for the deletion. And there's the primary one, which is blue. And you can find those in the CSS section. If you go to buttons, you'll find all of them. So see, this is super simple. It's all CSS classes for the different aspects. To have this floating on the side, on the extremes, I used a class that's pull right, just to have pull to the right. And then for the actual pictures, those are fonts, and you just give it a certain class, and you have the entire list of all the glyphs in the documentation in components at the beginning. So if you give it a different class, it will show a different image, and that's all that's done using fonts. So this is all hard-coded stuff. Again, this is not the Angular implementation. Regarding the form, it's just following the same kind of pattern. We have the same navigation bar. We have then we have input fields that have certain class. For the date, I'm using a type date input element, which is a HTML5 element that allows me to have a date picker natively without using external libraries. And then we just have a button and a link. Links can also have the class button, and then they just look like buttons. So that's what the user interface looks like. It's all basic Bootstrap stuff. Other than knowing that's a bunch of HTML elements with certain classes. That's really all there is to it. In this lesson, we're going to show a list of expenses in our app. We're also going to show the name of the app on the navigation bar, because now it just says hello. We'll have two controllers here. We'll have one controller that will be attached to the body element. So the scope for that controller will be the entire page. And then we'll have a second controller that will take care of this part of the container. That one will show the list of expenses. Let's take a look at app.js. We initiate our app. Our app is called expenses app. It has no dependencies so far. Then we define the controller home view controller, which is going to be in the body, and that's where we're going to enter the title of our app. Then we have expenses view controller, which has a list of expenses. Each expense has a description, an amount, and a date. Let's start by initiating our app by entering ng app and the name of our app, which is expenses app. Now we are creating the module, and that module is binded to the entire page, basically. Let's create our first controller, ng controller, in our body, home view controller. Now that we've linked our controller with our body, we have access to this variable, app title. Let's get rid of hello and type app title in double curly brackets instead. So now we can show the title of our app. In order for us to show all the elements, the first thing we need to do is attach the controller, ng controller, expenses view controller, and now add the list elements, which are going to have the class of list group text center, so that they show in a nice way with centered text. This has to be repeated many times, so we'll use the directive ng repeat. And we're going to iterate for each expense in expenses. Now, what's going to happen for each one of them? Let's reload the page to see that we get the elements. For each one of them, we want to show the amount. We'll show the $sign first, and now the amount, expense.amount. And we're also going to show the description. That should give us all of the expenses. We want to have the amount pulled to the left, so we're going to use some bootstrap classes here, just one called pull left on a span element. By doing that, we should be seeing this to the left. So there we go. We basically initiated our app. We attached the two controllers, and that gave us access to the scope variables that are in those controllers. So we were able to grab the title of our app and all of the expenses for which we show the amount and the description. Sometimes you want to modify the way something is shown to the user. You don't necessarily want to modify the objects, the variables that are behind, but for example, you might want to show some text in uppercase or some numbers with a certain kind of format. Angular has a very nice functionality called filters. In the documentation, you can find more details on each one of the filters. And in this lesson, I'm going to show you some basic ones. I have this example here, our app. You see that some of the numbers have different number of decimal. You might want to have them all shown with 2 decimals. Same with the text. Some people type their uppercase wrong or differently. So we're going to have all of this shown in uppercase. To use a filter, you attach it to an expression using this character. And now you enter the name of the filter that you want to use. In this case, we want to use the uppercase filter. So if we reload the page, I see that now all of the letters are in uppercase. You can also have parameters to filters. In this case, I'm going to use the number parameter, and I'm going to specify the number of decimals that I want shown. In this case, it's going to be 2. If I reload the page, now I can see that everything is formatted the same. So this is a very nice functionality You can find more information on the link that I've provided there. In single page applications, you have multiple views, multiple functionality without ever having to fully reload your page. Having said so, you might still want to have different URLs for different parts of this application. Because, for example, you might want to link to some content in that application, or you might want to be able to go back on the browser to another URL. Angular provides the ability to define custom routes to different parts of your app. So let's see how this is working on the Finish tab. When I go to New Expense, you saw that the expenses new was added after the hash. If I go back, now we have expenses. If I edit an expense, we have edit and then the number, the ID of the expense. So if we go to a different one, it's a different ID. If we want to delete, that also links to a different URL. On Angular, the custom URLs that you define go after the hash. If you go into more advanced options in the documentation, you can also use the exclamation sign after the hash or get rid of the hash altogether. But we're going to use the hash in this case. The first thing to do is to download from the Angular website, or using Bower if you're a more advanced user, the module Angular route. When you downloaded Angular originally, there was a dialog that asked if you wanted extra modules. In there you'll find route. So you need to include that one after Angular. Take a look at the container. In here we used to have all of that code showing all the lists, and now we don't have anything. Instead it says ngView. This is because we're going to be placing different views, different HTML files inside of this container according to the URL. Let's take a look at the file structure of what the project is going to look now. We have a new views folder, and in there we have two views, which are the two pages that we want to have. These are not the pages that I showed you when we introduced Bootstrap. In this case, they're just expenses is the same code that we had before inside of the container, but it's not an entire HTML page. That's basically what I mean. In terms of expense form, I'm just showing a sample page that we'll use later. It has a URL to the home and a URL to some non-existing route, just to show you how that can be handled too. But we won't cover that in this particular video. Let's go back to index. So we included route. There, in this part is where all the views are going to go. And the last thing we need to do in order to start using this is to actually inject this new module into our main application module. And this module is called ng route, like so. So after we've included this module, now we can start using it. In this lesson, we'll implement some routes in our application. The first step was to include the Angular route module, which you can download from the Angular website or using Bower. Then we need to specify the location where the different views will go. In this case, we want to keep the top navigation bar in all of our pages, but so we only want to replace what's inside of the container. As we put in different routes, we can have different views being shown here. We created a folder called views, and there's two files in it. One is the one that you're currently seeing, which shows all of the entries. The other one is an empty page, which will just show some text and has a URL to a non-existing route, because we're going to cover that case as well. So we've included ng route in our application. We've injected this module. Now we can start using it. We'll begin by creating the config method, which is used to define application level configuration. And in here we'll enter route provider, which is an object that we have access to since we included the route module, and that will allow us to define all these different routes, which views will be shown in each route, and which controller will take care of that particular route. See that we have two controllers here, one that shows the listing of elements, and the other one that's called almost the same, but it doesn't have an S in here, is the one that will show just some text for now. Later on, it'll be the form to create new entries and edit existing entries. Let's add each one of our routes. route provider, and then a method called when allows us to specify a single route. I'm going to put this here because we'll be putting many of them, so it's going to look a bit more organized if I do it this way. Okay, the first route you want to define usually is the route, the root. You don't have to, but we will in this case. So if we're in the root of our application, basically nothing after here, we will grab the template located in views, folder views, expenses.html. That's the template we'll load. The controller that will take care of this is this one here. So if I reload the page now, I'm on the root route. So before we were looking at this, but it was actually the finished example. So now we're just looking at it for the first time as according to what we've been coding. We get the exact same view that we used to have because it's loading this file and then it's using this controller. Let's add a second route for this same page. It's going to be expenses. So if we just type expenses, it will show it. Expenses. If I type something non-existent, it's not going to show anything. So how can we take care of that case? There's another method called otherwise. So otherwise, if it doesn't match any of the routes, take me to the root. I could have put any other URL in here. Let's add also one for the second view that we have. That one's going to be expenses/new. I can write anything I want here basically. In this case, I'm loading the other template file, expense form.html, and I'm using the other controller, expense view controller. Let's test this. So I'm going to write expenses new. To reload the page first. Expense new. Yes, and we get that second page. The second page will show us some text, and it has a link to a non-existing route as well, and see how that one takes you back home. In this lesson, we're going to introduce the concept of services. It's a very important concept in Angular. Services are objects that can contain a certain logic in your application, and you can access this object in different parts of your application. A service returns an object, and that object is only created once, as soon as you need it. And if you need it in different parts of your application, say in different controllers, you'll be accessing the exact same object. So there's only one instance of a service object. In our example, we have our list of expenses in our expenses view controller. But what if we wanted to access this somewhere else? Accessing one controller from another, it's not a very good practice. So we'll create a service that will take care of the expenses, and then we can inject that service in our controllers, and we'll be able to retrieve this list of elements in different parts of our application. We're already working with services here. Angular comes with many built-in services. Scope is basically a service. This is how you include services. Basically how we've been doing it so far. Route params is also a service that comes with the ng route module. And when I define this route at the beginning, I could have also done it this way, which I've updated, so that it's done in the same manner as with the controllers, with the string name and then the actual variable in here. Let's create a new service. We'll use the factory method for that. Think of it as a factory of objects. We're creating a new object. That's what comes out of a factory. The most simple implementation would be to create a service. We can call it however we want and return it. That's the most basic service you could have. But that doesn't do anything. So this service will have, you can of course have methods and properties, anything you want. You'll have something called entries. That will be the list of entries from our application. And now every time we want to access our entries, we just need to inject the expenses service. I want to call it expenses. And then just access the entries property. Let's include the service in the same way as we've included all of our other services so far. Expenses. And I want to have expenses equal to expenses.entries. That gives me access to all of my entries. reload the page and see that we're looking at the exact same data, but it's done now in a more modular way. Let's include also expenses on the second controller. So I'm gonna write expenses and expenses here. Now I have access to that same list of elements in this part. So I'm gonna add some text that's gonna show the first element, the description of the first element, which is food, as you can see. And that's something very simple. It just refers to the service. Entries, we grab the first entry and we grab its description. Let me reload the page and go to new expense. The ID is still undefined because we're not defining any ID in here. That's why it says undefined. But in here it says the first entry is food. Services are a great way to keep your code organized, and I strongly recommend that you use them. It can be something as basic as what I'm doing now, but we'll add a lot more logic into our service. In this lesson, we're going to add a very important component, which is the ability to add new elements to our list. So we add a new element in a form, and that element will be shown on the main listing. I've created a form in expenseform.html. It is a very simple form. It has a field for the description, the amount, the date. All of these fields have the ng model directive, which specifies which model they refer to. So in this case, we're expecting an object called expense in our scope, and that object should have a description, amount, and a date. Since Angular 1.3, when you're using HTML5 date fields, it is expected that you will deliver a date object, not just a string. We'll take care of that aspect because we were using strings previously in the following video. The save button has the ng click directive, which specifies a save function that we need to create. Let's go to the JavaScript code. This all occurs in expense view controller. I've included a new service called location, which comes with Angular, and that will allow me to send the user back to the listing after they click save. So I'm adding the service here and of course here as well. I want to distinguish between editing and creation of objects. In this case, we're only implementing creating new objects, but I still want to make sure that we're not editing. We're not in the process of editing one. And the way I'll do that is by checking for the ID parameter in the route. So if that parameter is not present, and it will never be 0 because it'll be numbers, then we'll create a new object. That new expense, we need to create that as a variable, put it in expense so that it will be linked to the form. And then once we save it, we'll take care of saving it in a bit. But let's create it first. It'll have an ID of say 7. ID will be the unique identifier of each element. We're hard coding this for now. Ideally, they should come from a server. Once you save something, the server will tell you what the unique ID is. Or you could have an approach that mixes local and server ID. Let's give it a description, something, amount, say 10, and date. As I said, it needs to be a date object. That's what's expected. If I just reload the page, go new expense, see how now it's linking, it's binding this object to the form. And if I change the values here, it's also changing the values of the actual object. So when I click save, I want to have a save function, and we'll give that task, the saving task will basically pass the ball to the service. So we're just going to say that the service is going to take care of saving that particular entry. We don't know how it's being done. The service will take care of it. In the controller, we just tell it, send this to the service, and then send the user back to the home page, which is, so we do location.path and specify the root of our app. What happens in our service? Let's take care of that as well. We need to create a function. It'll receive an entry as a parameter. It'll be an object. And we're simply going to push that new entry into entries. That's all we're doing. And this should be enough to have a form where we can add something new. and save it, and it shows on our list of elements. In this lesson, we're going to use the console of our browser to access the value of a service, and we'll take care of a small issue that we have pending, which has to do with the dates. I'll explain what's going on. Basically, we have our entries with a string for the dates, and when we're working with forms in Angular and when we're using the input field of type date, we need to be working with date objects. Let's take a look at what happens at the console. I'm going to create a new entry, and in the console we're going to type angular.element, and then we select a certain element of the DOM. We will not get access to things that are outside of the scope of that element. Let's select the document, the body of the document, but you can use normal JavaScript DOM selectors to find the element that you want. Then we're going to call this method called injector, and we'll finally get access to our services, in this case expenses. Expenses has only two properties, entries and the save method. See how we have both in here, an array called entries and a function called save. If we go to entries, check out any of the individual entries, you'll see that the date is a string, but on the last one, the date is actually a date object, because that's how Angular works when you're working with forms and input fields of type date. In order to take care of this, what we'll do is change all of our entries so that they have a date object in here. Later on in this application, we'll change them all back to string before we send them to the server, because we're assuming that the server will store them in this manner. That's just an assumption. So I've added an object here called myHelpers, where you could put different helper methods that you need, and I found one date object to string converter and one string to date object converter. This one was obtained from Stack Overflow, and this is just very simple constructor of a date object from a string that has this format, which is year, month, day. Right. So let's finally take care of this problem. So we'll iterate throughout this array using for each. That's a JavaScript method that you can use. It's a JavaScript feature. We'll get access to each one of the elements, and we'll change the date of that individual element to my helpers dot. This would be string to date object, and what we're converting is date. Now, if I reload the page, and if we check back in the console to see what's going on, I press the up arrow to get the last command. We go to entries, and then we check any of them and see how now they are date objects. So when we implement editing, the input field, the date input field, will show the correct value so that we can modify it. In this lesson, we'll implement a very basic ID generator so that the new entries that we create have also a unique ID. If you were connecting your application to the cloud, normally the cloud would give you the ID of each element, and when you create a new element, the cloud will return an ID for this new element. But if you're doing an offline application, you will have to generate your own local ways to identify each element so that you can have, say, routes to edit an element or to delete an element and whatnot. So let's start by defining another method in our service, which will be called getNewID. Every time that you call this method, you'll get a new unique identifier. The first time that we call this method, what we'll do in it is find the largest existing ID and add 1. When you call it after that, it'll just add 1 to that previous new ID. So the first thing we'll check is whether this new ID is defined. If it's already defined, then we'll increase its number by 1 and return it to the user so that they get the newest ID. That's a new unique ID. As I mentioned, if we haven't created this yet, we need to grab the largest existing ID, add 1. We'll use a method from the underscore library that we're including in our project called max. This method, what it does, it iterates through a collection of objects and it will find the object that has the highest value for a certain property that we specify. The object with the highest ID will be called entry max ID, and we'll get it from the underscore library. You always start with underscore, that's the name of the object the library provides. The method is called max. We'll iterate through service.entries, right? That's our collection. And on each one of them, we want to grab its ID so that this will give us the object with the largest ID. Now, the ID that I'm going to save is going to be equal to the ID of that object plus 1. Easy. And we return this to the user. Let's test this in the console. Remember how we can get access to the service, and we can of course get access to everything that service has, to all the methods that it has. So see how I'm calling it the first time, it gives me 7, the maximum was 6, it added 1. If we call it again, 8, 9, 10. Cool. Now we want a new ID generated for every new expense that we create. So that's very simple to implement. We have our save method here, which is to create a new entry, and we can access that entry, access its ID, which doesn't exist at the moment, because if I create one now and I access all my entries, you'll see that, say, the first one has an ID of 1, but the last one doesn't have one. So we want it to have one. Now it will have one. Entry.id equal service.getNewID. And now our new entries are going to have an ID. Let's make sure that's working. And yes, see how now we get ID 7, and if we create another one, it would be ID 8, and so forth. We want to be able to update our entries now, and the first thing we need to do is have some sort of helper method which allows us to find a particular entry by its unique ID. Because say I have an ID called 5, how can I get quickly which one of these entries that corresponds to, so that I can modify it further? Well, we need to implement that, and we'll do that in this lesson. I want to show you that we've already defined the route that's going to be used for editing. That's expenses/edit/ID. ID is the parameter that will pass. If we go to expenses.html inside of the views folder, see that I've already added the 2 buttons for editing and deletion. The delete button doesn't do anything. The one for editing is actually a link with the route that we've defined. Expense.id is an expression. We're using the double curly brackets to access the ID. Keep in mind that we're already using expense here for amount and for description, and now we're also using it for ID. So this gives us the correct URL for each one of the elements. Let's implement that find by ID or get by ID method in our service and have a test in the console. So this will take an ID as a parameter, and it should search for a particular ID in here and return that. You could easily do that with a loop, but there's also a utility function in _JS, the library we've included, which is called find. Find returns the first occurrence of a certain condition. So you put in a condition, you put in the array. When that condition is true, it will return that object. So in this case, we want to find one object where the object.id equals the ID that we are passing in here. Now the array, the collection is called service.entries, and this is where the condition will go. Entry will represent each one of the objects. We want to return, this will return a Boolean value, right? So this is entry.id equals ID. The first time this occurs, it will return an object, and that's it. That's what the method does. Let's have a play with this. For example, get by ID 1 will give us this first one. If we try, say, 5, we get the one that says bills, which is this one. if we create a new one, that one will have ID 7. So I'm going to try with ID 7, see what happens, and see how I got the new entry that we added. So now that we can select elements find elements by ID, we can implement the updating functionality. We are going to update entries now. We're going to finally implement that aspect. So let's go to our expense view controller, which takes care of the form. We had added previously that if the route didn't contain an ID, then we would create a new entry. We are now capable of handling the other case, and what we want now is be able to pass something to our scope so that we're editing, so that we can access the object. But I'm going to show you first what you don't want to do in this particular case. So we're going to access expenses, get by ID, and put in the ID that we're receiving. This will load the entry that contains this ID and we'll pass it to our scope so we can modify it. And you'll see why you don't want to do that. So let's grab this one, the one that says tickets. I'm going to change some stuff and I decide that I don't want to save, so I go cancel, which is basically a link that goes to the main page. But hey, it was edited and it looks horrible. So what happened here was that because of Angular's two-way data binding, we're actually modifying the real thing by modifying its HTML, its presence here in our view. So how can we avoid that? We can clone the object. There's a method in underscore.js called clone, which will copy all of the properties from one object into a brand new object, so that we're not modifying the real thing. See? Okay, cool. We've got that part now. Now we want to implement the saving. In save, what we had so far was generating a new ID and just pushing that new entry to our array. But in this case, we want something different. We want to retrieve that object and then we want to update it. We don't want to push something new. So there's two cases. There's the case when that object exists and the case when it doesn't exist. We're going to call this object that we read from the database, not the database, from our data set to update. And that will be service.getById. See how we're using getById a lot, and try to find it. If it finds it, then we want to update it. If it doesn't find it, then we should keep that code that we had to create a new entry. How can we update it? Basically, we want to copy all of the properties of this object into this existing object. And we are also going to use underscore.js for that. There's a method called extend. Extend will copy all of the properties from a certain source object into a target object. The target object goes first and the source object goes second. So this will copy all of these things that we modified into the existing object. Let's give this a try. So I'm going to change food for plain, change this value and this value as well, and save and see how it changed. We can go back and modify it again if we so want. So basically what we did was we cloned the object so that we weren't modifying the real thing in our form, and when we saved, we checked whether that existed or not, and if it didn't exist, we created it. If it existed, we modified it by extending it with the properties that the user entered. In this lesson, I'm going to show you a very simple example on how to use form validation in AngularJS. Validation in Angular is extracted from the DOM, from the attributes and types of fields that you're using. This is all pure HTML5, and Angular reads this information so that you don't have to type stuff that's already present in your HTML. Example, the required attribute, which is part of HTML5, Angular will know then that this field should be compulsory, and if the field is not being filled out, then this field is invalid. The other thing that Angular pays attention to is the type of element. So if we specify that a field is of number type, it will be invalid if it has something that's not a number. Same thing with date and other kinds of fields. Angular creates objects called by the name attribute of the form and the form fields. So for example, in this case, we'll have an object called expense form. We can access that object, and our object will have a few properties that will be of our interest. The first one is called valid. So that one will show us whether the form is valid or not. This is also present for individual fields, so you can also try an individual field, not just the whole form. In this case, it's not valid because two compulsory fields are empty. Let's write some numbers there, some information. So now it's valid. What if I type something that's not a number? Then it's invalid again. How can I use this to prevent the form from being saved? Because so far I can just save this. Well, we're going to use a simple Boolean operation here. So I'm going to have two things and the AND sign. So if the first expression is false, this whole thing will be false and this won't even be executed. Whereas if this is true, then the browser will try to run this one as well, and when it runs it, well, we're saving. So now, just by doing this, we have very basic form validation. But we can't save, and if we enter something valid, then we can save. Cool. Something else I want to show you. Angular adds specific CSS classes to the different values to the different states for forms and input fields. Let's inspect this and look at our console. See how the form, for example, shows class ngPristine. ngPristine means that it hasn't been touched yet. It hasn't been made. Nobody has written anything yet. So as soon as I start writing something, it's no longer pristine. It's now dirty. We also get the class ngInvalid required because one of the required fields is not being fulfilled, and we would get other kinds of classes if we have, for example, invalid number. The same thing applies for the individual form elements. We get invalid dirty, invalid number, ngTouched. So that gives you a lot of freedom. You can access these properties as well from the objects that are created. Last thing I want to show you, what if we want to show a form level error message when the form is not valid, but I don't want to show it at the beginning because at the beginning I haven't written anything yet. So of course it's not going to be valid, but I want to show it as invalid as soon as I start writing stuff. So I'm going to copy and paste that particular piece of code and add it on the top of the form. It's going to be a Twitter Bootstrap alert element. So I'm going to use the ngShow directive, which will show something if the expression inside is true. The expression inside that I want to test is the form dirty? So basically it's not pristine and is invalid. Let's give this a try. I reload the page, and of course the form is not dirty, it's pristine, but as soon as I start writing, it's now dirty and we get that error message. So by using this and specific CSS, you can add specific CSS classes and rules and find the full documentation here. By using all this stuff, you can make very simple but yet powerful and useful forms. In this lesson, I'm going to implement the ability to delete individual entries. So we have our listing so far showing the delete buttons, but they haven't done anything so far. I've added the ngClick directive and entered a method called remove, which receives as a parameter the expense that we want to get rid of. We need to create this method in our controller because it's not there at the moment. Let's go to expenses view controller and add that new method to our scope. That method receives as a parameter an expense, and we could search for that particular expense and eliminate it But I prefer to have all the data handling and all the logic in a service so that we could eventually use this same service somewhere else in our app. So I'm gonna assume that there's a method called remove in our service, and that one will receive expense as well. Let's now go up a little bit and add this method to our service. It's going to be a function receiving an entry. Basically, what we want to do is iterate through our list of elements and get rid of the one where the IDs match. We could easily do that with a for loop, but I prefer to use the underscore.js library for some of this data handling. There's a method called reject, which will give it a condition and it will return us the collection without the elements that satisfy that condition. So service.entries is going to be equal to this collection that we will get, which is going to be the method reject. We pass it the collection and we create a method here which will be tested upon each one of the individual elements of that list. It will return a boolean. The condition is that the ID is the same of the ID of the entry. So if that is true, that element will not be returned from this method. So basically this will give us the entire list, but except for one, the one where the IDs match. If I click remove now, hey, it's not deleting them. Well, it actually is deleting them. Let me go to new expense and go back. Why is that not being updated? I've said so many times that Angular is always updating everything and because of its data binding capabilities. Did I lie to you? No, I didn't. The thing is, traversing an array, as you may know, it's an expensive operation. You don't want to be doing that all the time or your processing power would skyrocket. Your application will be very slow. So when it comes to collections, you have to explicitly tell Angular to watch for changes. If it detects any changes, you can tell it what to do. In this case, we want to tell it to update the scope so that if there are changes in our service collection, I want the scope to be updated and sort of refreshed. So let's implement that here. We get our scope, we access a method called watch, and that one receives two functions as arguments. The first function is to specify what are we watching for. So it will return, I'll type return expenses.entries. That's what we're watching. The second parameter, it will receive that resulting object, let's call it entries, and here we tell it what to do if that is happening. Well, what we tell it, what we want to happen is just this same code. Basically, we want the scope to be updated at all times. That should do the job for us. Let's try again. Now, see how now if you click on delete, you get rid of individual entries. So now we've implemented deletion. In this lesson, we're going to create a custom HTML element in our app by creating an Angular directive. This is the listing of expenses. Everything that's inside the LI element is an individual expense. Imagine I could put this in a separate HTML file and refer to it here simply as expense by creating a magic non-existing HTML tag. Well, that's exactly what we're doing. That's possible thanks to Angular. Now, one word of advice. It's bad practice to create custom directives with just nouns like what I just did or verbs. What you need to do is add a prefix, because imagine that next year the new HTML6 specification comes out and the expense keyword is reserved for some new type of element. You don't want to run into those clashes, so you can minimize the risk by just adding your own prefix. In my case, I usually use ZVA from Zemba as a prefix, but you can add whichever prefix you want. The actual code for what's going to be in here, I've placed it in the views folder, expense.html. It's the exact same code, absolutely no changes. Now, what we need to do is define that directive in our JavaScript code. So I'm going to type app.directive. The name is going to be ZVA and then expense. So this is translated to camel case. As you can see, there's no dash in here, and this is in uppercase. function, and this function is going to return an object with the information about our directive. Directives cannot just be HTML tags, they can also be attributes, certain CSS classes that have a meaning in Angular, and also stuff you write in comments. But for now we're just going to use, there's no point in using anything but the element in this example. So we type E. Template. We could type our own HTML code here, for example, showing the expense description. And if we so wanted, let's not forget the double curly brackets. Say you want to show the expense amount. And close that div. Let's test this to see if it's doing anything at the moment. See how we can see the description and the price. But we don't want this. We don't want to have to type our HTML in our JavaScript code. That's just pretty ugly. So we want to have a template URL that allows us to load a file. The file is located in views and it's called expense.html. It's the exact same code that we had before. So see, it's easy. You create your own HTML tags using your application, and then you can have that working right out of the box. So we can still delete them, modify them if we so wanted. It works exactly the same, but using a custom directive. It's time to cloud enable our app. We want our apps to be able to connect to a server. This is a client-side tutorial series, so we won't get into what the server itself would look like. Instead, we'll simulate it with a hard-coded JSON file located in the data folder in our project. So if we look at our project, there's a folder called data, and we've simulated a response from the server. So we'll load this as if it was a server response. For the server side, you can use whichever technologies you're familiar with. It can be built in Node.js, PHP, Ruby on Rails, Python, Java, anything that you normally use on your server side. So instead of hard coding all of the entries like so, we're going to delete this. This is going to be an empty array, and it will be populated with the response we get from the server. The first thing you need to do is include the HTTP service in your expenses service. By including the HTTP service, we can make AJAX calls using different verbs. So you can use AJAX calls using get or post, or if you're doing a RESTful API, you can also do put and delete. But we'll do get, just to get a JSON file from the server. Now we're going to specify the URL of our server side. In your case, it could be http example.com and some location where the JSON file is going to be rendered. In this particular case, it'll be the data folder and the getAll.json file. If this is successful, we want to run our success method. That success method is going to include data or some variable name with the response from the server. What do we want to do with that response? Let's start by showing it in the console. But what we will want to do is, of course, populate service.entries. Let's reload the page. See how we got from the server that list of objects. Cool. Let's put that into entries. Also, remember that we need to take care of the dates, which come in MySQL format as strings. So we'll just reuse the same code that we were using before. Basically iterate through each one of them and using our helper, transform them to date objects. Should be all clear by then. What if there's an error in our call? If for example, the URL doesn't exist, or we get an error code from the server, we can use this error function method and say there was an error. So, for example, if for instance this URL didn't exist, well, in this case we got an error on the oh yeah, this should be alert, not error, of course. That makes sense. Then we get an alert that says error. So using the get service to make calls, AJAX calls, is very simple, as you can see. It's as simple as it is with jQuery. This is one of the strongest parts of jQuery, was how easy it made it to use AJAX calls, and as you can see, Angular makes it just as easy. In a cloud-connected app, you don't just want to read information, you also want to be able to push in new entries. So far, we've created an ID for these new entries locally, but in the case that I want to show you now, we're going to simulate that there's a server side out there that will send us a response when we create a new entry. That response, simulated by this file inside of data, create.json, will give us back a new ID. So what we're assuming here is that we send a new entry to the server server will carry out some validation, and if it's all good, it's going to save it into a database, and it's going to send us back the new ID for this object. So this get new ID method, we don't need it anymore. It won't be on the follow-up examples. If you were making an app that works locally, then you would need something like this to keep track of your information. Okay, so in save, in this part, we were taking care of the update of an entry, and we'll take care of that later on with the cloud, but for now, let's just focus on creating a new entry on the cloud. I'm going to use the HTTP server one more time, but in this case, the verb is going to be post. The URL will be data create.json. Was it create.json? Yes, create.json. We want to send something to the server this time, and we'll send the entire entry object. Upon success, we get a response from the server. That response will be an object with just one property, in this case, new ID. So our entry, the ID for our entry will be that new ID. We also want to add this to the list in our service. So we're going to push it to the end of the array. What if there's an error in the server? Could be a validation error, could be that the URL is not available. In that case, we can handle that error here. For now, just error. Let's give this a try. I'm going to create a new entry. We'll give it any description. And if we access this entry's information through the data, through the console, accessing our service and then the whole list, let's look at the last one. See how it has an ID of 100. So that came from the server in our assumption. And you can also see it on network that we called this server and we got this response. So as you can see, implementing AJAX calls and working with the cloud in AngularJS is extremely simple. It is time for us to implement updating entries in our server. How is this going to work? We're going to edit a particular entry, change some stuff, and when we click save, if it's all valid, we're going to send an AJAX call to our server. In our server side, in our imaginary server side, you'll be grabbing this information, you'll probably want to run some validation on it, and if it's all good, you're going to update your database entry. Then you want to notify the client by sending back a response that everything was good or there were some errors. In our example, everything was good, so we get the simulated AJAX response. You can have any kind of format for this, the one you normally use, the way you normally work as a developer. In our case, this is just a simple object that says success 1. That means that everything was successful. You could, of course, include any kind of information here. Now, let's go to our JavaScript code and implement this. We're going to use HTTP again. We're going to use post, but you could also use put if that's the way you normally work on your server. In my case, my local Apache storage that I'm using in this example doesn't support put, so I'm using post. But feel free to use whatever you normally use, the way you normally work in your server side. Data /update.json is the path, the URL where we're updating this. It could be example.com/yourapplication/ some other things. We want to send the entire object. Upon successful response, we get a response from the server. Upon successful request, we get a response from the server, and if that response contains a success property that is that exists, you could say equal 1 or have any kind of code that you want here. It really depends on how you want to define your responses. If that is all good, then we finally update our client-side listing, and we'll do that just by using the exact same code that we had before, which is extending update to update, which is the object on the list, with all the properties from entry. So all of the properties from entry will be copied onto to update. That's all this is doing. Let's have a test. Let's see if this works. Go update one entry, change it to foods, save. See how now it says foods in here. What happened in our network? Let's look at our network panel. We will find the AJAX call to update.json, and the response from the server was success 1. That means that your response was successful, therefore this code was executed. If for some reason your response wasn't successful, or you had if you had an error, we can add that code as well. Data status, you could have you could show an alert. So in some cases you'll return an error status from the server. In some web applications they don't return an error, they return a normal response, but for some reason it wasn't successful, so the information will be in it. So in this case, if we try that again and we try food 2, in this case that wasn't updated because it wasn't successful. So as you can see, updating the server is just working with AJAX again, just like when we did with creation. It's very, very simple. We can list elements from the cloud, we can create new elements, save existing elements, and what we need to implement now is the ability to delete elements from the cloud. How is this going to work? You're going to be able to click on the delete button, and that's going to make an AJAX call to our imaginary server. That server will run some validation on its own. If it's all good, it's going to delete the entry from the database, and it's going to notify the client back with a response. If that response indicates that the entry was removed, our client side will update itself. The response that we'll get will have this format, the same that we had when updating an entry. Basically, a simple object that's going to say success 1. We put that into delete.json inside of the data folder. Let's go to our service and implement this. Again, we're going to use HTTP, the service that allows us to make all these calls to the server. The verb will depend on your own implementation, so it could be post, it could be delete. It works in the exact same manner. In my case, I'm going to use post, and the URL will be data/delete.json. The parameter that we'll send, we won't send the entire object, there's no point, we're just going to send the ID of the object. Upon successful response, we get something back from a server. If that response that we get has the success property, then we can remove the data from our client side, because it's basically our server side telling us, yes, it worked, we were able to remove it, so now you can update your view. We already had the code to remove the entry from our client side, and I'm just going to copy and paste it. It's using the reject method by underscore. So a quick overview of this method again. Basically, it will iterate through this entire list. Each element that complies with this condition will be removed. That will be, of course, just one of the elements, because each element has a different ID. So only one element will have the same ID. This will return the array without those elements, and that's what we get for service.entries, which is what is shown here. And since we're watching that expression, upon changes, it will of course be updated too. You can have a case where there's some sort of error going on the server, like your server's down, the person doesn't have the permissions to edit that entry, or anything you can imagine. There's some validation issues. and in that case you can always just show something back. Also, you could add some else in here if there's a successful response as such, but for some reason it wasn't updated. You could have all sorts of cases here. That will really depend on your own implementation. Let's have a test. I have the list here. I can delete entries. What if we look at our network panel? We have all these calls to delete.json. If I inspect any of them, we'll get, well, of course, the same response in all of them because there's no real server side. What about the headers? We are sending the right parameters. Yes, you can see that here. In this case, it was ID 3, ID 6. Those are the ones that were removed from our list. So as you can see, implementing deletion on the server, I mean on the client side, but assuming there's a cloud, is extremely simple and very similar to creation and updating. Well done! You've completed the AngularJS course. I'm very proud of you. I really hope that you enjoyed this course, that you learned a lot of stuff. We created this basic single-page application from scratch. I really hope that you can use it as a starting point for your own projects. It doesn't have to be an entire single-page application. You can use AngularJS for little things on your website. I hope that, as we expected from our objectives, you're able now to use the basics of this framework in your own applications, in your own web development, that you feel confident with the framework, and it's a good starting point to get even more proficient with it. Feel free to check out zenba.com. We have courses on game development, on apps, on web development, and we're very interested in knowing what you think, what you thought about this course, how you found it. So if you can let us know, was it too advanced, was it too easy, are there things that we didn't cover that you wanted us to cover, just feel free to contact us, reach me in any of those channels, our social channels, and also we have our development communities, the Game Dev Academy, HTML5 Hive, for Spanish speakers, the IDEA app. We're always looking as well for people who want to collaborate and write content. So let me know if you're interested in that. And I would like to say thank you so much for taking this training, for taking this course, for completing it. I'm very happy because not many people complete our courses. That's something that we're always trying to push forward. So that's awesome. You completed the course. Thank you so much. I really look forward to hearing from you and seeing you in the next course.